Equilibrium involving ions is called ionic equilibrium. Substances that conduct electricity in their aqueous solution are called electrolytes. These electrolytes are further classified into strong electrolyte and weak electrolyte, where strong electrolytes on dissolution in water are ionized almost completely, while the weak electrolytes are only partially dissociated. We are studying ionic equilibrium with reference to acids and base, where we all know accordingly that any substance which turns blue litmus red and is sour to taste is called an acid, whereas any substance which turns a red litmus to blue, tastes bitter and feels soapy is called a base. Let us study the different concepts of acid and base. The first concept is Arrhenius concept. According to this concept, any substance that dissociates in water to give hydrogen ions H plus are acids, and any substance that produce hydroxyl ions OH minus is a base. Thus, HX is an acid because it liberates H plus. A proton is very reactive and therefore it cannot exist freely in the aqueous solution. So, it combines with water and forms hydronium ion. Thus, any substance which forms hydronium ion in water is called an acid. Thus, MOH is a base as it forms hydroxyl ion. The second concept is called Bronsted-Lowry concept. According to this concept, any substance that is capable of donating a hydrogen ion is called an acid, and any substance capable of accepting a hydrogen ion is called a base. Thus, acids are proton donors and bases are proton acceptors. Thus, ammonia adds a proton and forms ammonium cation. Here, ammonia is the base and ammonium cation is the conjugate acid. In this reaction, water acts as an acid because it loses a proton and forms OH minus ion. Thus, water is the acid and OH minus is the conjugate base. Water molecule acts as a proton donor and ammonia molecule acts as a proton acceptor. The acid-base pair that differs only by one proton is called a conjugate acid-base pair. Thus, OH minus is the conjugate base of the acid H2O and NH4 plus is the conjugate acid of the base NH3. As a rule, if the acid is strong, then the conjugate base is weak, and if the base is strong, then the conjugate acid is weak. Consider the second equation where HCl is acting as an acid and H2O is the base. Here, water is the base because it accepts the proton. Similarly, HCl is an acid because it loses a proton and forms Cl minus. The third concept is Lewis concept. According to this concept, an acid is a species which accepts electron pair and a base is a species which donates an electron pairs. Thus, electron deficient species are Lewis acid, while those species which can donate electrons are Lewis base. Next topic, ionic product of water. Certain species like water can act like both acid and base by donating a proton and forming OH minus ion and accepting a proton and forming hydronium ion. Thus, hydronium ion is the conjugate acid and OH minus is the conjugate base. The equilibrium for the above reaction can be shown like this, where K is equal to concentration of H3O plus multiplied by concentration of OH minus divided by concentration of H2O. Since H2O is a pure liquid, its concentration can be taken as a constant. We get an expression Kw is equal to H plus multiplied by OH minus, where Kw is called ionic product of water. It has been found that at 298 Kelvin, the concentration of H plus is 1 into 10 raised to minus 7. Since concentration of H plus is equal to concentration of OH minus in pure water, finally Kw will be equal to 1 into 10 raised to minus 14. Thus, if the concentration of H plus is more than OH minus, the given solution is acidic. If H plus is less than OH minus, the given solution is basic. And finally, when H plus is equal to OH minus, the given solution is neutral. Next topic, pH scale. Hydronium ion concentration in molarity is more conveniently expressed on a logarithmic scale known as the pH scale. The pH of a solution is defined as the negative logarithm to the base 10 of the activity of hydrogen ion. Activity of H plus is equal to molar concentration of H plus. So, from the definition of pH, pH is equal to negative log to the activity of H plus or negative log to the concentration of H plus. From the ionic product of water, we know that concentration of H plus, which is equal to concentration of OH minus for a neutral solution, the value is 10 raised to minus 7. Thus, if the value of the pH is 7, the given solution is neutral. If the pH is less than 7, it is acidic, and if the pH is more than 7, it is basic. From the definition of the ionic product of water, Kw is equal to H plus multiplied by OH minus, which is equal to 10 raised to minus 14. So, if we give negative log on all sides of the equation, then finally we get negative log of Kw will be equal to negative log of 10 raised to minus 14, or pKw is equal to 14, where pKw is equal to pH plus pOH.